This is lesson 3.2, Postulates and Theorems about Angle Pairs. Okay, so the first thing we're going to do here is we're going to take a look at this picture. We do have two lines and a transversal like we discussed in the previous lesson, and here's angle 1. So estimate the measure of angle 1 is our first task. Well, that looks like maybe an 80-degree angle, and hopefully you were thinking about the same. When we think about a 90-degree angle would have been about right here, so it's a little less than that, so maybe about 80. So now place angle 2. So let's place a 2 into this diagram so that it is a corresponding angle pair with angle 1. Remember that corresponding angles are angles that are in the same location based on their set of 4 angles here and here. So where are you going to put a 2? Hopefully you put it right there. They're both to the right of their transverse, or their line. Sorry about that. They're both to the right of their line and above the transversal. They're corresponding. What does the measure of angle 2 look like? Well, again, based on this being like 90 right here, it looks like maybe another 20 degrees, so maybe 110. So are angle 1 and angle 2 congruent? Well, no, they are definitely not. One's acute, one's obtuse, and they are not congruent. What we need to think about here is what do we have to change about this diagram to get angle 1 and 2 congruent to each other? Well, if we want angle 1, if that's 80 degrees, and we want angle 2 to maybe also be 80 degrees, we would need to rotate this line a little bit so that it kind of comes over here to make that angle 80, right? What would be true? What would have to be true about that line so that this angle here is the same as this angle here? Well, if you said that these two lines need to be parallel, you have noticed exactly what we need to know. So here's what I'm talking about based on that previous example, right? So now notice I made this blue line and this blue line parallel to each other. Let's see kind of what we notice here. So estimate the measure of angle 1. Well, let's see here. This is a 90-degree angle. That's maybe 45 degrees. Looks about half, right? And angle 2, again, corresponding angle pair. Well, that'll be right here because they are both above the blue line and they're both to the right of the transversal. That means they're in the same location, so corresponding. And what does the measure of angle 2 look like? Well, it looks exactly like this angle here. So it is also 45 degrees. Are they congruent? Yes, they most certainly are. It says, what do we need to do to change this? We don't need to change anything this time because they are congruent already. So here is the deal. We're going to learn some theorems on the next screen that tell us if we know that the two lines that are being cut by a transversal are parallel to each other, if we know they are parallel to each other, then we know quite a few things actually. So all of that leads us to these 4 important postulates and theorems. Notice that the first one is a postulate. The rest are theorems. It really is not super important that you remember which is which in what one means versus the other. A postulate is just something we allow to be true based on just kind of common knowledge in a way, and then theorems are always provable based on the other knowledge that we have. Don't worry too much about that right now. So here is a set of 4 postulates and theorems that tell us about angle pairs when 2 lines are parallel. So these theorems work exactly when I just said, when 2 lines are parallel, there's that tick mark again, and cut by a transversal. Okay, the first one says, if 2 lines are parallel and are cut by a transversal, that's these 2, P and Q, cut by a transversal T, then we will know that corresponding angles are congruent. 2 and 6 in this diagram are corresponding angles. They're in the same location. And we now know that they are congruent if the lines are parallel. Here is how we're going to write this in a proof. We're going to let you simplify this a little bit because otherwise it gets to be kind of a lot to write. We're going to write if we have parallel lines cut by a transversal. Now I know that looks a lot like an equal sign crossed out, which would mean not equal. Sometimes in some worksheets, you might also see this symbol. So this is going to represent two parallel lines cut by a transversal. This will also represent two parallel lines cut by a transversal, even though this looks like not parallel. But we're letting you abbreviate because otherwise it takes a long time to write this. So if two parallel lines are cut by a transversal, then corresponding, I'm going to abbreviate this as well, CORR, corresponding angles are congruent. If two parallel lines are crossed by a transversal, then corresponding angles are congruent. Always. It will always be true if the lines are parallel. So this is congruent to this. The next theorem says if two lines are parallel and cut by a transversal, then alternate interior angles are also going to be congruent. So here are alternate interior angles. Remember, alternate means different sides of the transversal, and they're both in the interior of the two parallel lines. So they look obviously congruent. If you look at this one, it looks obtuse, and this one down here is obtuse, and we have proofs of this, and we will show that during some of our examples. But for now, we will write the theorem in our shorthand here. If two parallel lines are cut by a transversal, then alternate, abbreviate like that, interior angles are congruent. The next one is about alternate exterior angles. And you will notice, once again, I'll put these tick marks in. So this angle was congruent to this angle for interior, alternate interior angles. And angle 1 and angle 8 are alternate exterior angles, and they also will be congruent. So if we have two parallel lines crossed by a transversal, then alternate exterior angles are congruent. Now, let's be really careful about this last one. Don't rush down here and write the same thing here because it's not going to be true. Let's look at the last one. So we have angle 3 and 5. You guys look carefully. Angle 3 is acute. Angle 5 is obtuse. Don't tell me that they're congruent because you know very well that they're not congruent. These two angles will actually end up being supplementary. If you think right now about 3 being congruent to this angle right here in this picture, do you see it? This angle right here, because they're alternate interior angles. And this angle we know and this angle are a linear pair, so they are supplementary. Well, if 5 is supplementary to this angle, and this angle is congruent to this angle, well, then we would know these two are supplementary as well. So that is a long-winded way to say if we have two parallel lines crossed by a transversal, then remember, these are called same side interior angles or consecutive interior angles, whichever one you want to use. I usually use same side. So then same side interior angles are supplementary. So a reminder that when we have same side interior angles, the S's will remind us that we need supplementary here, another S. So same side interior angles will be supplementary. Okay, so in this example, we know that the measure of angle 3 is 42 degrees. The deal is, now that we know that that's 42, we can fill in every other angle measure in this diagram based on just that. So go ahead and do this. Know vertical angles are congruent, so we know that. We know these are going to be a linear pair. We know this and this are corresponding, and if two lines are parallel, cut by a transversal, corresponding angles are congruent. We also know that these angles are alternate interior angles, and we know they will be congruent, and all sorts of things. So fill in all the angle measures, and then check back to see how you did. Okay, so hopefully you realize that every angle measure will be either 42 or 138 in this diagram based on those parallel lines. Okay, so the other information that we need to practice from those theorems is something like this. It says find the value of x. So this should look familiar from previous units where we would need to use algebra to solve for missing angle measures and that sort of thing. So Here we go. It says, given that R is parallel to S, it is super important that we have that information in our givens. Otherwise, we wouldn't be able to use our new theorems. So if the two lines are parallel and crossed by a transversal, we know these angles are what type of angles, by the way? Well, hopefully you're thinking alternate exterior angles. They're both in the exterior and they're on different sides of the transversal. So if the lines are parallel, we know alternate exterior angles are congruent. So we can write 3x minus 4 equals 113, and we will be able to solve this equation for x. The reason down here that we're going to use is that reason that I just verbally said. If two parallel lines are cut by a transversal, then we know alternate exterior angles are congruent. Okay, I'm going to leave that one for just a minute because I don't want to miss the second example here. You can go ahead and solve that for x at some point and get your value there. But this second one is important that we get to. So it says that T is parallel to R, so we can use our parallel line theorems. And I want you to notice these two angles that are given. This one here, 3x minus 7, and this one right here, x plus 5. Do they have any special angle pair relationship name? The answer is they don't. They do not. Because one is, they're not corresponding. They're not alternate interior. One's on the interior, one's on the exterior. They're not same side interior angles. So right now, we can't do anything with those two angles until we make a determination of a relationship that we know. So for example, the first thing I like to look for is vertical angles, like I mentioned earlier. So this angle here and this angle here are vertical angles. So I know vertical angles are congruent, so I could write that this angle right here is also 3x minus 7. Now, if that angle is 3x minus 7 and this angle is x plus 5, do these two angles have a special relationship? Well, the answer is yes. They are same side interior angles. And we know that if the lines are parallel, then same side interior angles are supplementary. So be careful with this one. We need to write 3x minus 7 plus x plus 5 equals 180 because they're same side interior angles and they are supplementary. So why do we have two reasons down here? Well, because the first thing we know we had to write is if angles are vertical, I'm going to abbreviate that too, then they are congruent. And we've known that from other lessons. The second reason we needed to use is if two lines are parallel and cut by a transversal, then same side interior angles are supplementary. We needed both of those reasons to end up writing this equation. All right, for time's sake, go ahead and solve these. I'm going to just include the answers and you can check to see how you did. But the goal is to understand the parallel line theorems and be able to write equations based on that information. Okay, so there's the work and the answers. X equals 39 and X equals 45.5 on those two.